Hello, my friends of Qatari Labs. Welcome to this webinar. This webinar is actually the third one, and this is automatic calibration of a transient pumping test with MODFLOW 6, Python FloPy, and skLearn. So what we are going to do here is we are going to review the sensibility analysis. We are going to get a parameter head generation overview and then I'm going to explain, more about not only about coding, but what are we doing with the code, okay? We are going to work with the scaling and transformation, and then we are going to split the data. This is steps from those are steps from the uh, from building a neural network with Python and scikit-learn. We are going to construct the regressor, and then we are going to evaluate the accuracy of our neural network, and then we are going to predict values. Okay, great. So let's start. Okay, we have changed our platform, and in this platform what we can do is we can give notifications. So that is why you have to be aware of the date, okay, pre before on your minds. Okay, great. So let's start with anaconda prompt. cd documents cd documents cd webinar. Okay, and then here we launch Jupyter Lab. Great. So we have launched Jupyter Lab on the webinar folder that you have placed under your on the webinar folder that you have placed under your we don't see your screen. Thank you, Stephen. I think that you are following. Okay, great. So we should have something like this. Okay, if you are here with me, please type 2. If you are here with me, please type 2. Great, great, great. Okay, so let's start. Okay, okay. So on the scripts, okay, there is this is the third part because actually there were three. This will be posted as a tutorial later on, okay, but there were three tutorials. Okay, the first one is this one, hatarilabs.com/. Okay, so first we have done this one, that is that um, we have uh, constructed a groundwater model, okay, over a confined aquifer with MODFLOW 6 and Python. Okay, so we have created the model in this, we have created the model here. Okay, this is a model that you could have created with model muse as well. Okay, so this is just a generic. Okay, so great. So, but what we have done next here, and this is the script that appears here, we have done a sensibility analysis. Okay, we have done a sensibility analysis. Okay, and then I'm going to do a explanation. Okay, with Salib, what we have done is we have, okay, in order to do, because for doing the neural network you need a data set, okay, and then you need a data set of several combinations of different parameters that will give you a certain water response, response on the groundwater flow system. If you understand that, please type 3. If you have any questions, let me know. I mean, if you understand, okay? Okay, if you understand that, okay, I think that you don't understand this. Okay, so let's see. For example, we have K. K. We have S, a specific storage. We have conductance, and then we can have various parameters. Okay, param 1, 2, and 3, and so on. Okay, and based on that, we construct a neural network that has some layers. Okay, so we can have many layers. No, we can have many nodes, I guess. Yeah, we construct the nodes. Okay, and then based on that, we can get, okay, in different layers, the value of the head in certain, okay, the value of the head in certain cell. Okay, if you understand drill here, please type 3. Okay, this is how a neural network will be applied to a groundwater flow model. Mhm. Okay, but since we are working, okay, on a transient model, we are not only going to represent one head, but we will be the head at certain time, at time 2, at time 3, at time 4, at time 6. Okay, so we have to construct this network, okay? And what we are going to do for building this network, we are going to use the data set of something that is called the sensibility analysis, okay? So what we are going to do is, okay, we define the parameters. For example, we define the K, and K has a certain range of parameters. Okay, so we have a certain range of parameters, value 1, 2, 3, 4, 5, 6, 6. Okay, and this will give us the certain combination of observation 1, observation 2, observation 3, and 4, and 6. Okay, so for every combination you will have a corresponding, for every combination you will have a corresponding observation value. Okay, a head, a corresponding calculated head on the cell. Okay, so or a combination of the heads in the different of the a combination of the head at different times. Okay, so and this is done with SALIB. Okay, this is done with SALIB on the sensibility analysis, because SALIB in the end actually gets the sensibility analysis, the sensibility, how sensible the model, but as well, okay, but as well create those data sets. Okay, so this is actually explained here. So okay, this is what to this is actually explained here. Okay, how to import a leaf flow in the here in this part we do the sensibility analysis. Okay, I have, that's why we are not going to do right now. Okay, but in this part we do a sensibility analysis over the model. Okay, and then but we are going to review this, okay, because the code for the sensibility analysis is here, so we are going to review. We are not going to type it, okay, so we are only going to review. So we import the package, we import the we have created here inside working tools a class, okay, that will help us because otherwise our code will be so large, okay, that defines the sim name, the working directory, the X name, and so on. Okay. Okay, and then there is a instance to load the simulation. Okay, so we load the simulation. So we have to change because actually you have a base model. Okay, and based on this base model, you create the you do many copies of that for every combination. So that is why you change the sim path. Okay, and then it changes the sim path to working model. Okay, and then it loads the package. Okay, and then it provides you the unique values for example the MPF, because actually from these values you are going to change. For example, for one combination it will be the k value of this layer to be, instead of being 1 10 to the minus 5, it will be 2 10 to the minus 5, for example, no? Okay, so but in order to replace that, you need to know the original value. If you understand that, please type 4. Okay, great. Okay, and then we create a function that actually for every, I mean, and this is based on these parameters. Okay, so we get the array. Okay, we look for this value and then we replace with our own value. Okay, so we open the model. Yeah, we look for the value and then we replace these values with our own values. Okay, and this is for k and this is for store activity. Okay, great. And then we write the simulation, then we wrote the simulation, and then we get the heads on this piezometer. Okay, great. If you have understood this, please type 5. Okay, if you have understood this, please type 5. Okay, great. I know this is too much to be condensed in just one webinar, and maybe in real life we can spend 3 days doing this exercise. Okay, and that will be awesome. Okay, but now you have the you have the two previous, you are going to have the two previous videos. Okay, and then now we are going to do what is here. Okay, the this class that is the neural network generation. Okay, so we have the function. Okay, and this is, we are going to run the model, but instead of being of the k of layer 2 to be 1 10 to the minus 5, it will be 2 10 to the minus 5. Instead of the layer 3 that is 1 10 to the minus 6, it will be 2 10 to the minus 6. Instead of the layer 4 that is 3 10 to the minus 5, it will be 4 10 to the minus 5. And the specific storage, I don't know which was the original value, but it will be 0.1, and then isotropy will be 12. Okay, great. Okay, so we run it. Okay, and then we have the corresponding heads at the different times. Okay, great. That is great. Okay, and then we do the, okay, but this is just for one. Okay, so this is for one combination, but we, in order to build the neural network, we need a lot of combinations. And for that, we are going to use SALIP, okay, that is a package for sensibility analysis, where we define our parameters. Okay, so K layer 1, layer 3, layer 4, SS, and isotropy. You can work with another parameters as well. Okay, and then you are going to define the range of values. Similar, okay, which of you, please type if you have experience with PEST. Nobody has experience with PEST? I don't believe these guys. Okay, please tell me if you have experience with PEST. No, yes or no? Yes, great, William. Who else? Just a little. Okay, great, great. I am here to hear from you because, and this is a little, thank you, just a little. Okay, The steps that we are going to cover here are kind of the same that we do with PES, because actually, well, PES you have to give a range of the values. Okay, okay. And so here we have the log param values, so we'll sample, and then okay, so we have, and the Sobol sample, I mean, is going to do a sampling over the, is going to do a sampling over the distribution of parameters. So for example, from 10 to the minus 6 to 10 to the minus 4, it will divide in certain, okay? So, and this parameter actually will determine how many values, I guess, it will be applied for each one. I mean, it's not exactly, because 16 times 5 actually doesn't give 192. Okay, but it will give you the, how many, I mean, as long as then you have more values, okay, the neural network will work better, but it takes around 6 hours or maybe 8 hours to run this on my computer. Okay, to run the numerical model for all the values here. Okay, so that is why I think that is okay. Okay, great. So, and then we save that, okay, and this is different for what it was, because we have to save the param values, okay, and okay, we have to save the param values, we have to run the model for every param combination, okay, and this is a lot because it's 192 times it will run the model, okay, and once we have it, okay, we got the time from the model, okay, we got the time from the model, okay, and then we plot the sensibility analysis. Okay, great. If you are here with me, please type 6. If you are here with me, please type 6. Okay, so something that says here is that the model, these are the first time step is steady, and the sensibilities really change over time. And this is, for me, was something, this for me was something very interesting. Okay, because for example, this is a pumping test of pumping and recovery. Okay, on a steady state, for example, the K of the layer 3 was really relevant. Okay, and then the anisotropy was really relevant. But actually, on the steady state here, there was nothing, because this is a flat land with just a general head boundary. Okay, so it's kind of something that no important no important flow was going through the model, okay? But when we started the pumping test, okay, the model at the beginning was more sensitive to the specific storage, and that is true, okay? But later on, okay, when supposedly we are reaching the steady state, or we are more close to the steady state, the model is more sensible to the K of the layer, okay, and is more sensible to the anisotropy, because the layer 3 is actually not in one layer, there are 3 layers, okay. Okay, so the layer is the layer group 3, but it's also divided in 3 layers, okay, great, until the model, until the pumping, until it stops, the pumping stops. When the pumping stops, actually there is this one, and then it starts to recovery. On the recovery is also more relevant to the specific storage, to the anisotropy, and later on the recovery is more relevant to K of layer 3, because I think that this one has recharge. Okay, if you have understood this, please type 6. 7. And now, based on this, because we store these values as well, we store these values. Based on this, we are going to do our neural network because we have the combinations of the parameters and the corresponding hydraulic responses. Okay, interesting, isn't that? Okay, so if you were, it is a pity that we are maybe, or that we are not going to do much here because yeah, it was more like instead of myself to do the to work with just pure Python because I know that there is some package called as PyEmu or like PES implementing MODFLOW that will actually have a great impact. Okay, that will actually have more things implemented. Okay, in the PES way, not in the pure Python way. Okay, and on PES, we are going to do kind of a certificate, like a small diploma of 3 months where we are just going to cover PES. Okay, PES, PyEmu, PES Homoemus, and PyEmu. Okay, great. If you have any interest in this PES diploma, please type it. There is no commitment, but it, it is, I mean, it's something, sometimes we post things that we think they work, but I don't think that people will be interested in it. Okay? Yeah, I mean, among hydrogeologists, uh, there is not much interaction through the network, to the, there is no so much feedback. Okay, if you have interested in this diploma, in this 3 month diploma on PES, please type yes. Please type no. Actually, there is no. Okay, please, but please type something. Okay, because we devote much time in doing this. Okay, but okay, if you are not interested in the PES, maybe propose something else. I mean, or maybe if you know everything, I mean, uh, okay, so let's see. And now let's see. Let's go to scripts. Only Bojin. No one else have interest. Okay, let's Pavel, Miguel Ángel, William, Mamun, Marina, and so on. Please type if you are will be interested or like if you have any other topic that we can develop. Okay. So let's start and let's start a new that it will be part one. Sven, are you there? Okay, thank you. Okay. Okay, so now we are going to type. Okay. So, okay, so we are going to define the import OS, import JSON, import pandas as PD, import numpy as np, import matplotlib.pyplot as plt, import seaborn as sns from skLearn preprocessing, import standard scalar, okay, from skLearn neural network, import mlp regressor, acá, and from working tools, import param model. Okay, great. Okay, here I have. If you are here with me, please type. Okay, great. If you are here with me, please type 8. I think that everybody has scikit installed because actually it comes with Anaconda. Great. Okay, so we are going to open the param values. Okay, log param values is equal to np load. Okay, so where they are in txt log param values backup because these are the param values that I have generated. If you have generated on the script yours, you can work with the log param values.mpy, but this is the ones that I have. Okay, log param values. Okay, so we can show the first 5 combinations. These are the first 5 combinations. Okay, great. Okay, great. And as well, we have the head values. Head values is an np load of txt head array backup. And okay. And this is kind of a trick. Okay, what is kind of a trick? What I'm doing this. Okay, I am doing this because I don't want to work with the whole dataset. Okay, because this is a pumping test that has pumping and has recovery. Okay, and this, I mean, I think that you know how football and another sports work. Okay, so at the beginning of the match, okay, you have one team in one field and then the other team in another field. But in the second part of the match, actually you change of you change of fields, okay? And for the neural network to understand that could be much different, okay? Yeah, and this is the same of doing pumping and recovering. It's kind of having the first time and the second time of the match. Okay, that is why here we just split the values for the recovery phase. Okay, so we are going to, you can do it for the, you can do it also for the pumping part, but now we are going to do for the recovery. Okay, or you can get the values just for certain time. I mean, because you want that the neural network work with, I mean, because your interest is that matches a certain times of the month. Okay, if you are here with me, please type 9. Okay, and these are the head values. Okay. Really interesting. There is a, okay, we see a lot of decimals, but we don't want to see those decimals. So this is set print options of precision equal to. So with that, every time that you plot anything in NumPy, we'll only have 2 decimals. Okay, it's amazing. Okay, if you are here with me, please type 1. If you are here with me, please type 1. You have any questions? You are so smart. Okay, great. Okay, now we are going to work with the neural network. So here we have the head scaler. We have to scale the values. Why we have to scale the values? Because the neural network work better if the mean value of your values is 0 and if the standard deviation is 1. Okay, that will make better. You will have a better prediction. Okay, so that for that you have a standard scaler. Okay, to fit the head values. Okay, head scaler. Okay, and then we are going to transform our head values scale is equal to head scaler transform head values. Okay, so we can say head values scaler. So these are the transform standard scaler. Okay, these are the transform values. Okay, great. So we have transformed our values. If you okay, great. And also the parameters. Okay, when we talk about log param, because actually you are not working with the param, you are working with the logarithmic of the param. Okay, why? Because we have to scale, and by setting up as a logarithmic, you are also scaling the value. Okay, so will be a standard scaler fit log param values param values scale is equal to param scaler dot transform log param values. Okay, and these are the parent values, the logarithm of the parent values, but scale as well. Okay, and then you have to check. Okay, so you can print head values scale, the mean of axis equals 0. Okay, and as well the standard deviation, because you want to know if they were properly scaled. The mean is close to 0 and the standard deviation is 1, and you are going to do the same for okay as well. You do the same. Okay, if you are here with me, please type 2. Please, if you are here with me, please type 2. Great, 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 great. Yeah, well, yeah. What is more important that you are going to have the video, and with the video you can explore later on. So my suggestion for the people that have the brain exploded like a popcorn, just try to follow and get the ideas, okay? And for the people that are actually typing and get it in, please continue. Huh? Don't be. Okay, so we are going to do from skLearn dot model selection import train test. Okay, so we can train our we can train our values, okay, with the whole data set, okay, but we are going to divide this. Why? Because we train with a certain values, okay, and then we are going to test the accuracy with another part of the values. Okay, for example, let me check. Yeah, a ver, let's see. Okay, so you have different values that will give you a response. Okay, yes, okay, so this is x1, y1, y2, y3. Okay, yeah. Okay, however, you are going to split that. Okay, you are going to split that. Okay, and this will be your train, and this will be your test. Okay, why? Because with the train you are going to construct the neural network. Okay, and with the test, okay, with the test, okay, your, how is called here, your regressor, your MPL regressor, multilayer perceptron regressor, okay, of test will give you some y of the test, okay, that you have to compare with the real ones, okay, and based on that you are going to define whether this is accurate, or whether, I mean, whether the neural network can actually predict the values of the heads or not. Okay, I have another comment that says, sorry to miss the rest, have to leave, so Mamu is leaving. I am really sorry. Okay, don't worry. Okay, if you are here with me, please type 3. Who else? No one? Yeah. Okay, so we are going to split our values, okay, and this will be, okay, great. So we have split it, okay, and then we do the regressor. Okay, if you want that the neural network give you a float number, okay, you do a regressor. But if you want that it give you a certain value, for example, gender, for example, location, for example, land cover or something like that, you don't use a regressor, you use a classifier. Okay, so in this case we are working with a regressor. So and here we use hidden layer sizes is equal to, so we are going to use 100 neurons in 3 layers for every layer, and the max iter is 50,000. and then we are going to feed that to the head train param train. Okay, we are going to work with this param train. Okay, so now we are working, we have done the regressor. Okay, we have done the regression. Okay, great. And then here we have that the param predict. Okay, so the predicted values we are going to predict for the test data set. Okay, so these are the predicted values. Okay, that we are going to compare with the actual values. Okay, so we are going to compare, these are the predicted values. Okay, and then we are going to uh, so here we are going to do a really great param names is equal to k of layer 2, k of layer 3, k. These are actually capital L's. Okay, fig. Okay, so what we are going to plot, and this is really interesting. Okay, we are going to plot how the predicted values of the parameters are, okay, for a head combination, how the predicted values of the parameter for a head combination are similar to the calculated parameters of the combination. Okay, so we are going to do the param predict. Okay, for the first one, that is of k of layer 2. Okay, and this is for the one, for the two. I have to close this. For the one, for the two. Okay, and this is the graph. If you have the graph here, please type 4. Great. Great, great, great. Okay, now we have to, okay, so for example, the model for the layer 4, okay, cannot predict. Okay, so if you have a value here, the predicted value is actually not corresponding. Okay, so the model actually cannot predict values on the layer 4 and the layer 2, but as we see, the layer 2 is not relevant on the sensibility, so actually doesn't matter. On the layer 3, it does a better work, but not that much. Okay, and the layer work can be improved, okay, because this is key on the sensibility, okay, and the predicted values aren't close to the real ones, okay, so we can improve that. On the specific storage is working really great, okay, and on the anisotropy not that much, okay, so we have on the anisotropy is actually not that specific. Okay, great. So this is a really great scope of the model. Okay, so and let's say from SciPy. Okay, so what we are going to do next? Okay, so we have observed data. Okay, we have observed data. Okay, but we are not interested. Okay, because the observed data is at the observed time, but we have to interpolate this data to the model times because actually that happens. Okay, in the field you have a certain observation point, but it doesn't coincide with your stress period. But we can work with that. So I say SciPy interpolate import interp 1D. Okay, so I say opsdf pt.read csv of model of pumping test of pumping observe pumping ops. Okay, so we are opening the why we are opening this, because in order to extract we are opening the observed values, and we do that in order to start the ops df head. Okay, in order to start the times of the model. Okay, so let's see. Okay, so we want the tot in, and we want to extract the times of the model without importing the model. Okay, so because here we are not importing the model. Time to list. Okay, time delta. This is the piezometer that we are working with. So, and these are the observed values. Okay, these are the observed values. Okay, and these are any time. I mean, these are times that do not correspond with our model. Okay, so what we are doing here is we are interp one ID of piezo df times seconds to list. Okay, of the time to list, we are going to interpolate those, comma, to the piezo, no, piezo df water table. We are going to interpolate the water table to list. Okay, so we create the interpolation function, and the interpolation will be, you can use it linear, but here we are going to use cubic. Okay, so we create the interpolation function. Okay, so we create a function that will interpolate the values, and then we are going to interpolate that to the to only the recovery phase. So the head model is equal to, but just for the recovery. Okay, so these are the interpolation functions. Okay, these are the, and then here we can if you want to see which is the difference among them, so you say PLT subplots. Okay, AX plot. Okay, you can say PSO. So you can plot PSODF times seconds, PSODF water elevation. Okay, and then say AX plot. Dot in14 head model, head model, and the marker, okay, will be an arrow. Okay, great. So if you are here with me, please type 5. If you are here with me, please type 5. Okay. So we see these are the observed values, okay, and these are the interpolated values, okay, and the interpolated values are interpolated to the time of the stress periods, and I think that the fit is okay. Okay, great, 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 great. Okay, so let's continue. Let's continue. You are doing amazing. This will be one of the most complicated webinars that I have actually given, and then you are copying with that. So actually, this is piezo data scale is equal to head. Okay, so now we are going to predict the model parameters. Okay, head scalar. Okay, transform head model. Okay, so these are the piezometers scaled. Piezo data scale. These are the scale piezometers. Head scalar. Okay, and the predicted values for our data set of the recovery are these values, but this is the logarithmic of the values. Okay, no, these are the transform. Okay, the scaled logarithmic of the values, so we have to transform the trans predict param values is equal to param scalar inverse transform of predict log param values. Okay, so and these are the this is the log param values. Okay, the predicted log param values. Okay, great. And the predicted values, I mean the predicted values as values of k will be predict param values is equal to np, because we are going to, the log in numpy is the log, the not the log of place 10, but is the natural logarithm. Okay, transparent values of 0. So the predict variant values is this. Okay, so this is the k of layer 4, this is k of layer 3, k of layer 2, k of layer 3, this is k of layer 4, this is the specific storage, and this is the anisotropy. Okay, there is a lot of anisotropy here. Okay, and then we save that. Okay, we save that. Okay, we save as a numpy array. Okay, so let's see. Here on the sensibility analysis, there was this function. Okay, we copy the function, Control C, because it's the same function here. Okay, great. And then we run the function for the, okay, we run the function here. Okay, but instead of for these values, we are going to run the function for the predicted param values 0, predicted param values 1, predicted param values 2, predicted param values 3, and here the predicted param values 4. So we run the values for this. We have to run this and this. Predicted param values. Okay, here. Okay, now it's running for our combination. It's running. Okay, it's running for you. Please type 6. If it's running for you, please type 6. Running for no one? Mm, 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 mm. Okay, if it's running for you, please type 6. No one. If you need more time, let me know. You have any question, let me know. If you are still there, let me know. If you are still there, let me know. Need more time? Yeah, thank you. Okay, has finished. Okay, and these are the predicted values. So now we are going to compare these predicted values, okay, to the observed values. Okay, so fig, and let's see, AX is equal to PLT subplots of fixed size is equal to 10,5. So I say AX plot PSODF time seconds. PSODF. Okay. Label observe. Label observe. These are observed values. Observe it. Okay. AX dot plot dot dot im dot im piezo data. Label predicted. Okay, and here you have this is your model. Okay, this Miguel, so actually you don't know how it really works, your computer or the neural network? Yeah, I know. I mean, it's really few time to understand how you build your networks and so on. And then I work with something. Okay, so it's too many things together, but you will have the code and then you will have the documentation. That is research, man. Okay, but this is the reality. The reality that says that this is the model calibrated with these parameters, and this is how accurate it is as well. Okay, just to remember that you have more stress, and here you have a better fit on the first stage of recovery. Why do you have the stage of here a better fit of the because you have more points, while here you have less points, so or the points are more distantiated. So actually whether it can fit here or here, that is depends on the neural network. Okay, well, that was it. Okay, so we wanted to prove this, and then we make it proof. There is no unique solution, because if you go to this notebook, okay, you are going to see that for another combination you also have an acceptable solution. Okay, so or if you rerun this The parameters will be different, but it's the combination of the parameters that ones that give you a better result. Okay, if you don't want this, for example, if for some parameter, for example, you say, no, look, my anisotropies could not be higher than 20, so you have to go to the sensibility and then you have to restrict the range. Okay. Okay, so that's it. There is a lot of I don't expect that you have better what I expect here at this stage is that you have more questions than at the beginning, but all I have also I am your groundwater coach. Okay, so if you want to learn groundwater modeling, I am your groundwater coach, and my advice is to keep searching. You have 50% of all the steps that you need to apply this to your own model. Okay, this is a great advantage because otherwise you are in what is called the loneliness of groundwater models, where you have a lot of questions, a lot of doubts, and no clear clues about how to continue. Okay, just to mention that we have hatarilabs.com that the webinar in groundwater modeling with FloPy is coming. Okay, so okay, so we wait to see you there. Okay, and you have entered to our shop hatarilabs.com, and here on this you have a lot of diplomas that you can take async. The one that will be synchronous is the FloPy, but there are more material here, and as well we have a lot of courses that you can take. And just to remember that if you take our courses, you are supporting our research. Okay, can we have this file? Which file are you talking about, Vojin? The file with code, the base is this one, the one that is called P2, that is the one that I have followed. Okay. Thank you for being here to the end of this, the most complicated webinar that I have given. Please, just to say us goodbye, please type the city where you are connected. Thank you. The city where you're connected, and kind of a brief opinion on this. Okay, yeah, you are going to have the. Okay, I will stop the recording.